we are going to begin discussing equilibrium. So what we've done in the last several classes, we talked about supply sort of by itself, and we talked about demand by itself. Now what we're going to do is put them together. And to do this, I'm going to start with looking at some slides we talked about on one of the first days of class. We said an incentive is an opportunity to make yourself better off, and it's something that induces a person to act. And we said that people respond to incentives by acting to make themselves better off. So I bring this up because I'm going to use this definition of incentive to learn a new term, which is called an equilibrium. An equilibrium is a situation where nobody has an incentive to do something different. So in an equilibrium, nobody has an incentive to do something different than what they're doing. A grocery store, one checkout line has a very long line and the other has a short line. Is this an equilibrium? The answer here is B. No, it's not an equilibrium. Why? Because if you are the person at the end of the checkout line, of the long line, well, you would be better off if you were at the end of the short line. So you have an incentive to move from the long line to the short line. So I'm going to put a flow chart up here for thinking about how can we determine if a situation is in equilibrium. So is this an equilibrium? Does someone have an incentive to change their behavior? If the answer is no, then we've reached an equilibrium. That's the definition of an equilibrium. Nobody has an incentive to do something different. Equilibrium. Okay, well maybe if someone does have an incentive to change their behavior, well then, we expect the person to act on that incentive, right? That's what an incentive is. It's something that induces you to act. All right, person acts on their incentive. All right, are we at an equilibrium now? Well, is there someone else with an incentive to change their behavior? So this would be person acts on incentive. That's going to be person at the back of the line moves to the short line. Okay, does someone else have an incentive to change their behavior? Does the second to last person in the long line have an incentive to change their behavior? Maybe even after, maybe they still would have a shorter wait if they were in the short line. So we keep doing this and people keep moving from the long line to the short line. And one of the things this makes us think about is that in general, we think that because we keep going around in this circle as long as someone has an incentive, it seems that most situations should move toward an equilibrium. Let's get back to our shopping line example. So which of the following is true if there is one long line and one short line? The answer here is C. People in the long line will move to the short line. Eventually, an equilibrium is reached. So I bring up that idea of an equilibrium because we are now going to use this concept to look at supply and demand together. And really the most important thing to get out of this is we're going to learn how prices are determined. You remember we said at the beginning of demand that prices are determined by buyers and sellers. We said it's sort of like with scissors, you need both blades to cut the paper. We need both buyers and sellers to get prices. So talked about how if I'm a seller of milk, the higher the price, the more milk I will supply. This is the idea. The price went up, so now I will start having dairy cows instead of cows for beef. I'll have cows instead of chickens, maybe. So for whatever reason, when the price of milk goes up, that's going to lead me to supply more milk. This is just the direct result of the fact that supply slopes up. Price goes up, quantity supplied goes up. For a buyer, the higher the price, the less milk I will demand. Maybe I'll drink juice, maybe I'll drink almond milk, maybe I'll just drink less milk and switch to water. In any case, this is just a direct result of the fact that demand slopes down. Price goes up, quantity demanded goes down. This is just a reminder because we're going to put supply and demand on a graph together for the first time. So here is a downward sloping demand curve. And let's suppose that we have a price of 40. At a price of 40, we have 30 units demanded. So if the price is 40, people will buy 30 units. Now let's look at supply. If the price is 40, there will be 70 units supplied. So what do we have? We have, again, 30 with a price of 40, 30 units demanded, for 70 units supplied. So let's illustrate this. So here we have the Marios are buyers. Each Mario represents 10 buyers. The Luigis are sellers. Each Luigi is 10 sellers. So we have 3 Marios, 10 Luigis. All these Marios say, hey, we're willing to buy for 40. The Luigis say, we're willing to sell for 40. So they come together, and there's 4 Luigis left out. And this one says, wait, you are getting ready to pay Mario, you're getting ready to pay this Luigi 40. Well, you know what? I'll sell it to you for 39. And so Mario says, okay, well, I'd rather pay 39 than 40. So Mario moves to this Luigi. And then what happens? Well, we still have now this Luigi and these 3 Luigis are left out. One of them says, wait, I'll sell it to you for 38, and so on. So what we see here is a surplus. Quantity supplied exceeds quantity demanded. So whenever we have this situation here, there's always going to be Luigis left out. There's always going to be people with product that they want to get rid of where there's no buyer. So this is a surplus. A surplus is the market condition in which quantity supplied exceeds the quantity demanded. When this happens, some suppliers will not sell their goods. Remember, there are always going to be 4 Luigis left out. These suppliers have an incentive to cut their prices and undercut the other suppliers. This means that prices will not be stable if a surplus exists. So because someone has an incentive to do something different, this is not an equilibrium. Okay, so we know if the price is up here, we don't have an equilibrium. How about if the price is down here? Well, in this case, if the price is 20, then we're going to get 30 units supplied and 70 units demanded. So now we're going to make the Marios the sellers. So there's 30 units supplied. We have 7 Luigis because there are 70 units demanded. So all these Marios say, hey, we're willing to sell for 20. All these Luigis are willing to buy for 20. Notice that, as we would expect, when the price went down, we're getting fewer units supplied. So this is, the price of milk went way down. So now we're growing less. I'm going to be providing less milk, and I'm going to switch to cows that are used for beef or chickens or something. And price went down, so we have lots of people wanting to buy milk. And so the Marios and the Luigis come together. And what happens? We have 4 Luigis, who are in this case are buyers, who are left without milk. So this Luigi says, wait, you're getting ready to sell to him for 20. I'll pay you 21. So Mario says, oh, I'd rather have 21 than 20. So Mario moves over. And again, that means this Luigi might say, well, wait a second, I will pay you 22 for it, and so on. This is what's known as a shortage. A shortage is the market condition in which the quantity demanded exceeds the quantity supplied. When this happens, some buyers will be unable to buy the good. They will have an incentive to offer more money for the good. So prices will not be stable if a shortage exists. This is not an equilibrium because somebody has an incentive to do something different. Okay, well, think about what's going on here. What we said is that the buyers have an incentive to offer more, so that's going to nudge the price up. And in the surplus scenario, the sellers have an incentive to undercut each other, pushing the price down. So let's see what happens when we get to the middle, right here, where quantity supplied equals quantity demanded, which here is going to happen at a price of 30. So at a price of 30, we can see there are 50 units supplied and 50 units demanded, which means we have 5 Marios and 5 Luigis. So we have 5 Marios who are all willing to sell for 30, 5 Luigis who are all willing to buy for 30. They come together and Everyone's happy. We have reached an equilibrium. So in the absence of government restrictions, we do not expect surpluses or shortages to last for long. Why? Because whenever there is a surplus, we see the sellers undercut each other to push the price down to equilibrium. When there's a shortage, the buyers outbid each other to push the price up to an equilibrium. So that means in most markets we observe an equilibrium. No buyer willing to pay the market price is left out. No seller willing to sell at the market price is left out. There is no one trying to just undercut or just pay above the market price. Nobody has an incentive to change their behavior. That's an equilibrium. So prices are stable. Let's think a little bit more about prices. So I've seen it said that a price is a signal wrapped up in an incentive. So here's what I mean by that. Let's think about Uber surge pricing. So you probably know Uber surge pricing is when in a time of great demand, so you think about a concert lets out and there's lots of people wanting a ride home, the price of an Uber goes up. Uber surge pricing is a signal that there are too many drivers, too many riders, and not enough drivers. So essentially, a lot of riders aren't going to be able to get a ride because there just aren't that many people out driving. Well, the high prices create incentives for both buyers and sellers. So buyers are the riders, sellers are the drivers. For the buyers, the incentive is, hey, you should consider another form of transportation. Take a taxi home or walk home or call a friend to come give you a ride. Sellers says the incentive for sellers when they see that high price is drivers at home should get on the road and start picking up riders. So if you're on the couch, the incentive now is you should do something other than what you're doing, right? Maybe you don't want to drive if you were going to make $10 an hour, but surge pricing says you're going to make $30 an hour. Well, you now have an incentive to go drive. So we're going to talk now a little bit more about shortages. And this is a term that's often misused, at least from an economist's perspective. So this slide shows all different times when things are referred to as shortages. So Harvard said there was a housing shortage. This said there was going to be a banana shortage. Talks about a labor shortage. So we'll look at I'll focus on this banana shortage as an example. So officials say a fungus is affecting the soil so it can't produce fruit. It could lead to a shortage and a price increase. Well, if you think about what we've learned about supply and demand, this really it's not really a shortage, it's just a shift in supply, right? You can think about it as the technology for growing bananas has decreased. So the reason it's easy to, there's a tendency to call something a shortage if it is expensive and there's a small supply on the market. So one of the main places you'll see this is housing. You hear about a housing shortage in big cities, right? So you might think about a housing shortage in New York, and people say that there's a shortage there. Why do they say that? Well, housing's really expensive, and there's not much of it available. Well, you could say the same thing about Super Bowl tickets, right? You don't really think much about a shortage of Super Bowl tickets. They're extremely expensive. Notice that you used to be able to get in for $12. This was in 2012. The highest price to get in was $1,200, and this is a ticket stub from a little more recently, and the price was $2,250 face value. So Super Bowl tickets are very expensive, and there just aren't that many of them, so however many people you can put in the stadium. Well, so which of the following meets the economic definition of a shortage? The answer here is B. Rent control laws resulted in more people wanting to rent apartments than there were apartments available. So if you look at A and C, A is an example of a decrease in supply. So it leads to increased prices and fewer vacationers. However, if you have the money, if you're willing to pay the price, you can get a beachfront property, right? So is there a shortage of these beachfront properties in July? They're hard to come by and they're very expensive, but if you're willing to pay the price, you can get them. Similarly, so with Super Bowl tickets, they cost much more than face value. If you're willing to pay for it, you can get a Super Bowl ticket. You can go up 20 minutes before the game, stand outside, and there is someone for $5,000 who will sell you a Super Bowl ticket. So the reason B is the correct answer is, and we'll talk more about rent control soon, the reason B is the answer is because even if you're willing to pay the price for rental, the price of an apartment, whatever the price that rent control allows them to charge, there are more people wanting to rent than there are apartments available. So when you're trying to answer one of these questions, ask yourself, if you are willing to pay the market price, can you get the product? If so, there's not a shortage. And in both A and C, if you're willing to pay for the apartment, for the beachfront property or the Super Bowl tickets, you can get them. The reason B is a shortage is because there are lots of people willing to pay the market price because the market price is forced to be lower than it would be otherwise. So next we are going to talk about price ceilings. So a price ceiling is the maximum legal price at which a good can be sold. So some examples of this: US gasoline prices in the 1970s, there were price ceilings. There are some ticket resale laws that restrict how much you can sell, like a Super Bowl or a concert ticket for. Housing in some cities has price ceilings. And what you get with this is you get lots of demand and not much supplied. This is what we'd expect to happen, right? If you force the price to be low, that means you have a reduction in the quantity demanded, or an increase in the quantity demanded and a reduction in the quantity supplied, right? So if milk is really cheap, I'm going to want to buy a lot of it. And if I'm a dairy farmer, I'm not going to want to supply much of it. That means you're going to want the good. You're willing to pay the ceiling price for it, whatever we're forcing the price to be. Well, you can't get it because, again, there's lots of people who want to buy it at that price, but not many people willing to sell it at that price. This is something that can cause a shortage. So if we were to go back and look at the Mario and Luigi example, when do we get a shortage? When this exact situation happens. We have lots of units demanded, not much supplied. So a price ceiling is not going to solve a shortage. A price ceiling is what causes a shortage. Now let's learn a little bit of terminology and we'll look at some graphs. Price ceilings can be binding or non-binding. So a non-binding ceiling is above the equilibrium price and has no effect. A binding ceiling is below the equilibrium price and affects prices. So let me show you a graph I think will better explain what we mean. So we're going to say this is a graph of the gasoline market. Notice that in equilibrium, we have a price of $2 and a quantity of 25 million gallons. What if there was a price ceiling of $2.50? Remember, a price ceiling says the price cannot be above this level. So it's illegal to charge more than $2.50 for gasoline. Well, the price was never going to be $2.50 anyway. The price was already left on its own. The price wants to be $2. This would be essentially the same result as if you put a price ceiling of $100 on gasoline. You set a law, no one can charge more than $100 for a gallon of gasoline. Well, no one's doing that anyway. So this is referred to as a non-binding ceiling. It doesn't actually affect the market. It doesn't actually affect prices paid. And so we can reduce this. We can even reduce. So 225 ceiling is still non-binding because it's above the market price. Go a little more. A price ceiling of $2, that is the lowest non-binding ceiling. It's equal to the equilibrium price. So if you think about it, why is that the lowest non-binding ceiling? Well, it still is not actually affecting prices. The price was going to be $2. The price ceiling is $2, so you're still able to charge exactly $2. Now let's think about if we go below that level. So if we take our price ceiling down to $1.50, now we have a binding price ceiling. The price wants to be $2. Left on its own, it'll get to an equilibrium price of $2. The price ceiling says, nope, you're not allowed to have a price that high. The price ceiling forces the price down to $1.50. And with a price ceiling of $1.50, we have suppliers producing 20 units and buyers demanding 30 units. So what do we have? We have a shortage, right? This is exactly what we thought would happen. When we have a price ceiling forcing the price to be low, we have lots of units demanded, not many units supplied. So what is the difference between quantity demanded and quantity supplied? So how much is our shortage? It's just 30 units demanded minus 20 units supplied, which means that there is a shortage of 10 units. Now let's look at a couple of questions. Suppose the US federal government decides to place a price ceiling on milk. What is the lowest possible non-binding ceiling? The answer here is C. The way that we find this is by looking for the equilibrium price. We said the lowest possible non-binding price ceiling is the equilibrium price, so we need to find the point where quantity demanded equals quantity supplied, and that happens right here at a price of $3.40. Suppose a price ceiling of $3 is imposed. What is the resulting shortage? The answer here is B, $10. B, 10 units. Because if we look at the price ceiling of $3, well, the price wants to be $3.40. We're forcing it to be 3, which means we have a binding price ceiling. We're forcing it lower than the equilibrium price. 46 demanded, only 36 supplied, so we have a shortage of 10 units. So when we're trying to remember, do price ceilings need to be low or high? What's binding, what's non-binding? Well, price ceilings should be low to have an impact. You can think about it, a low ceiling is the one that's going to affect you, right? If we're in a room with a 20-foot ceiling, you're not going to have to think about ducking. A low ceiling of 4 feet, that's going to have an impact. And price ceilings are generally understood to be bad for producers, right? If I am being forced to sell my milk at a low price, I'm not going to want to do that. It's going to be bad for me. They're generally intended to benefit consumers. So rent control laws exist. Price ceilings, which are price ceilings for apartments, those exist because people are sort of wanting to help out consumers and wanting them to not have to pay so much for apartments. The actual effects we're going to see are more complicated, and that is what we'll discuss next time. We are going to continue discussing equilibrium. If you remember, last time we started to discuss price ceilings. What we're going to do today is think about the effects of them. Remember, I sort of left us with a little bit of a cliffhanger, and I said they're intended to benefit consumers, but the actual effects are more complicated. And today we're going to think more about those actual effects. So one effect we have is a decrease in quantity supplied. This is just a straightforward application of the law of supply. So if our equilibrium price wants to be where supply and demand intersect, if we set a price ceiling at that line, then what we're going to see is a decrease in quantity supply. Again, it's a very straightforward application. If we set a price ceiling here, what that means is we get movement along the supply curve and our quantity supplied decreases. So you can think of it as if there's a price ceiling on oil, we're not going to see that huge oil derrick built. Notice that this is really giving us the opposite thing that we need. When we are implementing price ceilings because we think something is too expensive, it's because there's not enough of it. And so if we restrict the price of oil, we're actually not going to fix our problem of not enough oil. In fact, we're going to exacerbate it, right? So before we didn't have much oil and it was expensive. And so what we did was we said, all right, let's limit the price of oil. Well, what that does is actually limit the supply of oil, so you're in even worse shape after you make the law. The next thing we get is queuing or waiting in line. So this happened most famously with the oil lines when there were price ceilings on oil. So essentially what would happen is, in equilibrium, what would happen? So with no restrictions, the price of oil would go up until there were as many people wanting to pay that high price for oil as there was oil available. Well, with price restrictions in place, we had lots of people wanting to buy it, not much gasoline available. So what happened was, if you wanted gasoline and I wanted gasoline, and everyone in our neighborhood wants gasoline, what we do is we all get up and we'll see who can get up the earliest and go get in line for gasoline. And so we get in line, we wait in line, and if you're at the front of the line, then you get your gasoline. If you're not, then they run out of gasoline and you come back tomorrow. One way you could think about this is that what's happened is we have replaced a financial cost with a time cost, right? So instead of paying $4 per gallon for gasoline, you're now paying $2 per gallon for gasoline, plus an hour of your time spent waiting in line. Another thing that can happen is there arises some sort of black market, which is basically illegal sales that bypass the price ceiling. So basically, you think about it as I'm someone renting out an apartment and I know you need an apartment, and so I sort of, without us telling anyone, you give me more than I'm allowed to charge for the apartment. You're happy because you got an apartment. I'm happy because I got more money for it. Another example, so when I was at University of North Carolina, the big sort of event there was when Duke came and played basketball. The university actually warned of honor code violations if you sold your tickets. So they were concerned about a black market for people selling tickets. There's essentially a price ceiling of $0 on those tickets. You're not allowed to sell them at all. Right? Another thing is that people always figure out some way to bypass restrictions. So there are ticket packages available for the Super Bowl. So the NFL, I don't know if it's a legal thing or they just don't want to be known as they themselves selling tickets above face value. So what they have done is that the NFL would have a opportunity for you to buy a pregame ticket package. And so you're getting the ticket plus the pregame party, and then as a result, they charge more than face value. Another thing, I thought this was pretty clever, was overnight parking. So during the times of gas lines, one of the things that gas stations did was they started to offer overnight parking. And what they said was, we are also offering parking. And if you pay us to park at our gas station overnight, you get to be first in line the next morning. And so people would pay for overnight parking, even though they had no actual interest in parking at the gas station. They just wanted to be able to buy their gasoline. And that was another win. So I paid for overnight parking. I'm happy because I got to get gasoline. The gas station is happy because they got extra money because I paid them for overnight parking, which essentially what I was doing was paying them more for gasoline. So these are the effects of price ceilings. We're going to now think about the most common kind of price ceiling, which is rent control. So this is the Monica and Rachel's apartment from Friends. Neither of them seem to make much money. This is like a really nice apartment in Manhattan. I think I saw it estimated would go for like $4,000 or $5,000 a month. And in one episode, they mentioned that the reason they have it is because it's rent controlled. I think Monica sort of inherited from her grandma or something. So what are the negative effects of rent control? First thing we have is a reduction in supply. So what that means is we just talked about how we'll see a reduction in quantity supplied if there's a price ceiling on oil, as an example. Well, we also see this occurring with rent control. So this is what was going to be an apartment building in Ontario. Well, 1,000 planned rental units convert to condos in wake of the Ontario rent control expansion. So instead of renting them out as rental units, because Ontario passed laws about rent control, this building would have been subject to it. So instead, they said, you know what, we're not going to deal with these rent control laws. We will just sell them right now as condos. And if you think about it, that is a reduction in the supply of rental units, right? So if I wanted to rent an apartment, now these apartments are gone. They're off the market. Someone has sold them to buyers as condos. Another thing that happens is you can be less likely to move. So New York, for example, has strict rent control laws. It has the highest housing turnover rate of the top 10 US cities. So Monica and Rachel do not want to move. Why? Because they're going to have a hard time finding another rent-controlled apartment that's as good of a value as the one they're in. So this has come up because you'll see when parents become empty nesters and all their kids move out, they're sort of in these large houses, and they would probably prefer to be in a smaller house. It would make more sense. That would open up housing for, instead of 2 adults living in a 4-bedroom house, you'd have, 5 or 6 young single people as roommates living in this house. However, parents are concerned that they're not going to be able to find anywhere suitable to live because of these housing restrictions. So they stay in the same house, and results in there being fewer housing units available. Another thing we get is deterioration and lack of investment. So these are pictures that I found in a New York Times article about rent-controlled apartments that fall into really bad shape. Why? Because the landlord knows that they're renting it out for much less than market rate. They know that if the current tenant leaves, there will be someone else willing to rent. So they don't really feel any incentive to fix minor problems when they break. They don't feel incentive to clean the place up, paint it every once in a while, because if you don't like it, just leave. Someone else will take it. This is really price ceilings are one of the few areas where economists agree. So there was asked a survey if they agree, economists say if they agreed that the amount and quality of broadly available rental housing in cities that have used them has a positive impact. And there was strong disagreement with this. There is general consensus among economists that price ceilings are actually sort of do harm to people who they're trying to help. They actually make it harder to find affordable rental housing. This is an article that was in a prestigious economics journal in 2019. They looked at the effects of a San Francisco law on rent control. San Francisco is another place with with housing shortages and very strict rent control. They find rent control limits renters' mobility, as we expected. They find that landlords reduce rental housing supplies by 15%, as we expected. And they say the lost rental housing supply likely drove up market rents in the long run, ultimately undermining the goals of the law. I have one last price ceiling example. So we've talked about surge pricing and how it multiplies Uber fares in times of greater demand. Remember, we said this creates several incentives. On the driver's side, it will increase supply because I was hanging out at home. Now I see the price goes up. All right, I'll go make some extra money. It also will reduce demand, specifically a reduction in quantity of Uber rides demanded. So I might carpool, I might just decide to stay home tonight, etc. And overall, that means we're more likely to find a ride, right? So after the concert ends, because the price is so high, we're going to have a lot more people willing to drive, fewer people wanting a ride. So we're more likely to reach an equilibrium where everyone who's willing to pay the price can get a ride. Well, on New Year's Eve 2015, a computer glitch led to a 26-minute period without surge pricing in New York City. So you notice it happened from a little after 1 a.m. to almost 2 a.m. This is, an hour after the ball drops. There's tons of people wanting to leave. And here's what happened during that 26-minute window. So the orange shading is the time when surge pricing went away. So I'll go back. You notice that before this, the surge rate was almost triple. Afterwards, it went to 6 times the regular rate. So when it went to a single 1x no surge rate, that was a huge change in price. And so what happened? Well, the number of requests went way up. That's what you'd expect, right? You're getting ready to go home and you're deciding what to do, and you check your Uber and you're wondering how bad the surge price is going to be, and you see that there's no surge price in effect. So right away you hit request ride, and so does everyone else. So our number of requests goes way up. Well, the number of requests goes way up. Chances are our number of drivers also went down, right? Because I'm driving around, all of a sudden I see that I'm not going to get paid extra. I'm thinking, I'm driving around Manhattan on New Year's Eve. It's a zoo. I'd rather be anywhere than here. Good thing I'm making lots of money. Oh, look at my phone. They're not even paying me extra. So I'm going home. So now we have lots of people requesting rides. Not that many people willing to give rides. So the ETA goes way up. So now because there's just, think about it as queuing. You're not physically standing in a line, but Uber has put you in some sort of order and you're waiting to get to the top of the virtual order for someone to come pick you up. And finally what happened was the completion rate went way down. So normally we expect an Uber completion rate of close to 100%, right? If you request an Uber, you will get one. You might have to wait a few minutes, but you'll get one. However, at this time, because there were so many people requesting rides and not nearly enough drivers, only less than a quarter of ride requests actually turned into someone getting in the Uber and getting home. So there's a nice summary of it here. There was an economics paper written about it. I thought this was a good summary of price ceilings in general. The rate at which ride requests were fulfilled fell steeply. A small number of riders got a good deal, but most were left without a ride at all. You can think about it as There's a few Monica and Rachels who get to have a really, really nice apartment at a low price. But there are lots of people who can't get any apartment at all because of these rent control laws. Now we are going to talk about price floors. So a price floor is the minimum legal price at which a good can be sold. So a binding price floor means the minimum price is above the equilibrium price. So the most common price floor we see is minimum wage laws. So workers are the suppliers of labor, firms are the demanders of labor. The hourly wage is the price of labor. So we'll think about it from a minimum wage perspective. Let me go back a slide and think about what we mean by binding. So a binding price floor means the minimum price is above the equilibrium price. So if we were to make a price floor, a minimum wage price floor of 25 cents, that would be a non-binding price floor, right? That is whatever the equilibrium wage would be without restrictions, it would not be 25 cents. There are not enough people willing to work for 25 cents an hour. So a binding price floor is when minimum wage actually makes a difference, with the minimum wage is above what the wage would be in restriction, without the restrictions. And so minimum wage, it says it is illegal to work or to hire someone at the equilibrium wage. So what we would expect to happen, this is just basic theory, suggests that minimum wage laws should lead to fewer workers being hired. And all this is based on is the fact that the demand slopes down. So if we have our equilibrium wage here, minimum wage laws force the wage to go up here. Well, it used to be that these firms wanted to hire this many people. Now they only want to hire this many people. We have this surplus of labor, so we have lots of people wanting a job. However, we have fewer people being hired. We would have hired this many people. Now we're only hiring this many. So this is based, again, just on the law of demand. All we have to do to believe this is true is believe that demand slopes down. When price goes up, so in this case, the price of an employee, we get a reduction in demand, which in this case means reduced hiring. So we expect a similar takeaway to price ceilings. Those who get the minimum wage jobs do better. So if you're one of the people who gets hired, you're loving the minimum wage. But many people who can't get a job do worse, right? So all the people in this region who would have been able to get a job otherwise are left with no job at all. So they're worse off. So this is the theory. And again, it's pretty basic, first month of Econ 101 type results. However, actual data, when they've done research on this, is ambiguous or predicts small effects. So some will say that minimum wage laws have no effect on the number of people hired. Some will say maybe it's some, but it's small. Some will say it actually increases the number of people hired. And in general, there's much less consensus among economists than there is with rent control. So this is a survey of economists asking if they agree that minimum wage laws will decrease the employment rate of low-wage workers. So will minimum wage laws kill jobs? And you see the most common answer was uncertain. The data is really mixed and it's hard to see any clear results. So demand for labor. So why is this? So this is sort of an unusual thing we're seeing, that we have really basic theory says one thing, but when we do all sorts of research, we just don't see it. So here's some of the reasons. Demand for labor may be inelastic. And so we talk about inelastic demand in micro. We don't really talk it in this class. Essentially what this means is demand for labor might not really be very sensitive to the price of labor. So we'll think about McDonald's as a minimum wage job. And it might be that McDonald's, they need 30 workers at their store. And whether the minimum wage is $7 or $9, they're still going to hire 30 workers. That's just how many people they've decided they need for their store. Another idea is that maybe minimum wage workers spend most of that extra income, which may create jobs. So Walmart will say they pay their workers minimum wage goes up. A lot of those workers spend the extra money at Walmart, which increases the demand for Walmart employees. There's also a possibility that some results may not show up in employment statistics. So this is sort of an application of the idea where we showed the apartments that were in bad shape because the landlords knew they were rent controlled and there would be someone else willing to take them. Well, similarly, we could think about, all right, I know that the minimum wage is high and there's plenty of people who are willing to take your job if you quit. So this will lead me as the manager to take some certain actions. So maybe you're less likely to hire certain groups. So I have a bunch of applications. I'm going to decide that if I see some adults and teenagers, I trust adults more. I think they're more responsible. So I hire the adult, not the teenager. Loss of fringe benefits or deterioration of working conditions. This is, you know what? I know there's lots of people wanting to take this job. I'm paying you more than I would in equilibrium. So I'm not going to make much of an effort to make your job enjoyable. If you don't like it, leave, I'll replace you. Now what we're going to think about are changes in supply and demand. We already saw how supply and demand can shift. Now what we're going to do is consider the effect of those shifts on prices and quantity. And so remember, I said when we were learning about change in demand versus change in quantity demanded, I said that it was important for us to differentiate between these and really understand what an increase in demand is versus an increase in quantity demanded. This is why. This is some important stuff we're going to learn, and we're going to use that terminology. So let's look at an example. So this is something called Bang energy drink, which is, I guess, a new version of Red Bull or something. An advertising campaign successfully convinces consumers that Bang energy drink is healthy and delicious. How does this affect the price and quantity of Bang? So this is the kind of question you will very often see on an exam or a practice problem. And I'm going to walk us through a 5-step process to solve it. So first thing we do, what changes supply or demand, and what is the direction of the shift? So let's try to answer that. An advertising campaign successfully convinces consumers that Bang energy drink is healthy and delicious. How does this affect supply or demand? Right, the answer here is B. We have an increase in demand. Essentially what we've done is we have shifted tastes and preferences. Next, draw the supply and demand graph and include both the pre-change and post-change demand curves. So here we have our original supply and demand. Now we want to draw what demand looks like after the advertising campaign, which we said leads to an increase in demand. So D1 is the demand curve before the ad campaign. What is the demand curve after the ad campaign? The answer here is B. An increase in demand shifts it to the right from D1 to B. Next, we find the pre-change and post-change equilibrium points and compare them to see how did price and quantity change. So, what are the effects on price and quantity when we move from D1 to D2? So again, look at equilibrium before, look at equilibrium after the change. The answer here is A, both price and quantity increase. How do we know? We started off here. We wind up here. So we moved up and to the right. So that means that price went up and quantity went up. And again, think about it, this is why we're running an ad, right? We want more people to buy our product and we want them to be willing to pay more for it. Now we're going to think about multiple changes. Here's what I mean. Sometimes both supply and demand can change. When that happens, we want to consider each change individually. So basically, we do steps 1 through 5 for the supply change, and we do steps 1 through 5 for the demand change. We think of them completely separately. Then we add up the effects. Another thing to notice is that net effects can be indeterminate. So what indeterminate means is we don't know if it went up or down. So if one change moves price up, one change moves price down, from what we do in this class, we're not going to know which is bigger. So what that means, we're not going to know the net effect on price. Similarly, if one change moves Q up, one moves Q down. So at the same time as the advertising campaign, Bang opens up a new factory that reduces the cost of making the drink. Well, that is, if you think about that like an improvement in technology, that shifts supply to the right. Well, now let's compare our equilibrium points. Equilibrium used to be here. Now it moves to here. So we move down and to the right. What does down and to the right mean? So down means price goes down, up quantity moving to the right means quantity goes up. So now we just figure out the net effect. So this was the effect of our ad campaign. Remember we said that was an increase in demand, price and quantity both go up. Now it's the effect of our factory. We said that's an increase in supply, price goes down, quantity goes up. So now we just combine them. Well, for price, one moves price up, one change moves price down. We don't know which is bigger, so the net effect there is unknown. For quantity, the ad spending says there'll be more units. Demand says there'll be more units. The new factory says there'll be more units. So our net effect is that we will have more units. Right? So that is the end of equilibrium.